Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you.
In the previous set of video tutorials, we worked exclusively with daytime imagery, whether it being the LandScan series of daytime imagery or whether it was Sentinel. And we did a whole lot of different calculations and images and classifications, etc. And before that, we delved a little bit into the nightlight data set. Another very useful data set that I find to work with fairly often is the various population data sets. So in general, when I do spatial work on any specific region of interest, the first three data sets that I explore is the nighttime light data set, is the daytime imagery data set, whether it be LandScan or Sentinel, depending on my time horizon, and then the population data sets. Those are the typical first three data sets that I tend to work with when I do any spatial work on a specific region of interest. So this video tutorial and the next couple of video tutorials will focus predominantly on the population data sets. And there are especially three data sets that we're going to work with. We're going to work with WorldPop, SEDAC, and LandScan. Okay, so that is the three population data sets that we can work with: WorldPop, SEDAC, and LandScan. LandScan never used to be on the Google Earth Engine platform. It used to only be LandSat, WorldPop, and SEDAC that you can generate via the Google Earth platform. But lately, they've also added LandScan. So in terms of LandScan, you can either go directly to their website and download it from there, or you actually now can generate it from Google Earth Engine. Okay, so before we go into the code editor to generate the data, let's quickly go and look at the three different data sets. Okay, so we go to our Google Earth Engine website, and we go to our datasets platform. So you click on there, and then in the search bar, let's go for the first one, WorldPop, and we just select, and there we go. There is the various, there's the WorldPop data set. So let's click on that one there. Let's see it. Oh, sorry, this is the SEDAC one. Okay, nonetheless, doesn't matter. Let's go again to data set, my data set tab. Let's go for WorldPop again. WorldPop. Let's go for that one, not world population. Let's go for that. And there is our WorldPop one. Yep, where's WorldPop? And then let's go to datasets again, our dataset tab. Within our Earth Engine platform, we go to dataset, and we in the search bar set LandScan, not to be confused with LandSat. So we press LandScan, we find the word there, we click on it, and we're going to get the tag for it. There it is, and let's open it. Okay, so I'm just going to rearrange it a bit so that we'll start with WorldPop. So WorldPop is provided by WorldPop, so we can go to their website by just right-clicking. I'm just going to go open in a new tab. Anyway, let's continue with it while it's opening. It's available from 2020 to 2021, basically 20 years, 2020. So it's basically 21 years or 20 years. There's the unique identifier. Remember the band. The band is population. Okay, that's important. And it's the estimated number of people residing in each grid cell. Now, what is a grid cell? Grid cell is your pixel. size. Remember, we worked in, when we looked at your resolution, when we worked at Landsat and Sentinel, we said that Landsat is on 30 meter resolution, which is that square block, which is 30 meters, and Sentinel was 10 meters, which is that little block. So that's what we call a grid cell, is the square, which is that pixel. And here it says the resolution is 92 meters. Okay, so 92 meters. We'll go and have a look now and see how it practices. There's the minimum value and the maximum value, 21,000 people in that pixel. Okay, so 20,000 people, 21,171 maximum in that pixel. That's quite a high amount of people in a very that's a very dense populated area. Okay, and there's our trusted code at the bottom. Okay, so that's our description, availability, etc. Let's go to the website. There's the website. Let's just say accept, and there you can go to about us, methods and tools, the data, the news. Here you can find everything around WorldPop, the methodology that they use, etc., etc. Okay, so if you want more information, go there. Okay, so second one, so that's WorldPop. I found WorldPop to be the better of the three, my personal opinion. And that's why I always start with WorldPop. And the reason is that its spatial resolution is much smaller than the others. But we'll see now, okay? So as I said, I found WorldPop to be the most promising and the most useful. Anyway, so the next one is SEDAC. It is produced by the NASA SEDAC at the Center of International Earth Science Information Network, again, from 2000 to 2020. Okay, and this is density numbers. Okay, they also we'll see now. Okay, so let's just click on this. Let's go to their website while it's opening. Let's go on. Its bands also 9 to 7 meters, and this is population density, the estimated number per square kilometer, which is in. So it's not the number of people per pixel. Okay, it's a number of people per square kilometer within that pixel. Okay, so they will give you 7. Let's say 7 is the number, so it's 7 people per square kilometer within that pixel. Okay, so it's a little bit of a different measurement than WorldPop. Okay, so this is a density number, not a quantity, total amount of people per pixel. But so if there is within that square, there's 3 square kilometers, then it will be 7 times 3, 21 will be the total then, for example. Okay, and there's the trusted code for that one. Okay, so let's go to the population. So it's a Socioeconomic Data and Application Center, SEDAC. And then again, same as in WorldPop, there's all the resources that you need to quote them, to get the methodology, to get to the data sets, and all the derived data sets that they also have in here. Okay, so you'll see there, that's population density. They do have the nice thing about SEDAC is they also give it to you in a Excel spreadsheet, which is very, very nice to work. So from a calculation or spreadsheet point of view, SEDAC is the better option. But from an imagery point of view, I found WorldPop to be the better option. Okay, so you can go in here, themes. Let's click on themes, and you can go to population there. And you'll get the different. So there's your, okay, so log in. Okay, let's just wait until it will log in us. Okay, so while we're there, okay, it's logging in. Okay, so that is SEDAC. So it's just logging in there. No, I don't want to. Okay, so we'll log in a bit later. But anyway, log in. Let's just take away. Okay, so it's log in. Okay, there it is again. Population, there is the population divided vector point. So there's your spreadsheet, your Excel spreadsheet. Okay, it's located there. Download. You can go to there. And they also give a total. They give a total and a square kilometer in this specific data set. Okay, and that is based on points. Anyway. Okay, so the last one that you can delve with is LandScan. As I said, this one normally you don't used to be on the Earth Engine platform. It is now. I don't know exactly when it's got on the platform, but luckily it is now. And you say that, and you can read there, and it is most up to date. It is actually till 2022. Okay, so WorldPop, in terms of the images, for me is the better one. The LandScan in terms of the Excel spreadsheet is for me the better one. And then LandScan in terms of the most up-to-date data is LandScan. So pick and choose. That's why I always go for all three. Okay, so it is produced by Oak Ridge. So let's just right-click there and go to Oak Ridge. Okay, there it is. It should give us the map. Why is it not giving us the map? Anyway, so you can go to its website and go and find the population details. Population. I should actually put in LandScan. So you go to LandScan and search for the LandScan, and you should find it there. Okay. Don't see it now. They recently changed their website. So I would basically just go and press Google LandScan. And there we go. And there's the website. Okay. So it actually is much better there. And as I said, from here, you can actually go and download the data. Okay. You can press download and you can actually download your region of interest, the data for your region of interest. Anyway, enough said of that. So that's LandScan. Okay. The beauty of it is it's most recent data available. And there is the band is B1. You see, this is 1,000 meters. Okay. So the others were, let's go 92 meters, 900. So, okay. So let's have a look again. WorldPop is 92 meters, where SEDAC is almost 1,000 meters, and then obviously LandScan is also 1,000 meters. So if you want to look at the spatial resolution and WorldPop, that's why I use WorldPop, because it's got the best imagery. It's got the lowest resolution. Okay, and its band is B1. This one is band is population density, but they also have a population count, which is, let's go in there and go again, SEDAC. If we go there, SEDAC, you'll see they should have a population count, gridded population, gridded population. Okay, here's the density. Okay, so here's a population count. Okay, so there's the population count. You'll see population count. The estimate number of persons per grid cell. Okay, so that's the one that we're going to use, not the density one. But you can see it's 297, which is the same as LandScan, roughly the same as LandScan, which is much higher than WorldPop. Okay, so there's the three that I typically work with, is WorldPop, population count per pixel, SEDAC, population count per pixel, and then LandScan, population count per pixel. And okay, so there's the three data sets. Okay, so let's just delete that one. Okay, so you just basically, I'm not going to create three separate code editors for this. I just copied and pasted in one code editor or one script or one project. Okay, so there's my project. There it is. Okay, so I've created a new project which I call Pop Tutorial 1. That's the project name that I've created. Okay, then first thing I upload my region of interest, which is the one that we've been using all along for most of the daytime, etc., etc. So I upload this. I'm not going to call it Roy. I'm calling it table in this side, but that's up to you. The only reason why I'm leaving it a table is because in my script, all the references are tables. So it's easier just to change this to table than to change everything in the script to Roy. But it's exactly the same thing. So I leave it there. Okay, I load my region of interest. I map center it. Remember that I've used this point marker. Click it normally somewhere in the middle. So let's do it. I normally click on that and just click on somewhere in the middle. And then the geometry will come up here. And from here, I click on that little thingamajig. I get to copy the coordinates, copy it, paste it in there, and then I delete it. And then it will center around this. Remember, that's your coordinates that will center, which is somewhere here. And then this is your zoom level. And play around with your zoom level. And there's my trusted clip tool. So these things, loading the region of interest, adding the region of interest to the map, center the map, and creating my clip tool is standard practice. It's like save and run and save, remember? So that's us practice. So I go to my first data set, which is WorldPop data set. Okay, and the reason I use WorldPop, as I said, because from an image point of view, it's much better simply because of its low resolution. Okay, and for each of these data sets, I'm going to create two images, the beginning image and the end image. Okay, the beginning image and the end image. Okay, so my normal script is I give my data a name. So in this case, I call it W for WorldPop, my WorldPop dataset 2020. Okay, it's an image collection because there's 20 images, obviously, from 2020 to 2020, 2000 to 2020. There's 20 images, which is an image collection. And then there is my unique identifier, which is coming from my WorldPop. There's my identifier. Okay, so there it sits. And then I select my band. Now this is again a single band variable. Data imagery is multi-band. This is single band, similar to my nighttime lights, okay, which is also a single band. So I select my band, I select my date, and I clip it to my region of interest. So that's your standard code. You copy and paste it for all of them. You just change the unique identifier and obviously the variable name and your band. But the code stays exactly the same, or the format of the code. So here I create a generate the 2020 image for population count. And here I generate the 2020 after 2000 image. Okay, so in fact there's an update here. I can make it 2021 here. So here I download the 2021 image. Let me just make sure all my references are correct. Come on. So this must be 2000. And this is a 2021 now. And this is a 2021. And therefore I'm going to upload 2021. I'm going to upload 21. And we're going to export 2021. Come on. 2021. Okay. So, yeah. And then obviously I'm going to do a sum calculation. Now you can do a medium calculation. You can do a sum calculation or mean calculation. That's again up to you. Okay. Now sum calculations should give us the total population count. And that's why I'm using sum, because I'm interested in the total population within each pixel or within each square. Okay, remember this is WorldPop, so in that 92 square, the 92 meters square. That's what I'm looking for. I'm looking for the sum. Okay, so I'm going to generate two images, two sum images, and I'm going to clip it for my region of interest. There's my visualization parameter. I have a maximum 1,000 people per pixel or per 92 square. And there's my color palette. Where do I get my color palette? I get it from here. You can just click on any geometry, go to that little nut there, choose your colors, copy and paste it, and I create the color palette of 1, 2, 3, 4, 5, 6 classes. Now again, you can decide any of these colors. You can decide the classes, whether it's 3 classes, 4 classes, 5 classes, or categories, what the colors is. So this is black, and then it goes up to red. So this is black, and then we've got green, and then we've got, I think, purple, blue, pink, and red, if I'm not mistaken. The minimum 0, and then I'm going to add these 2 images based on that visualization parameters to my map. Okay, and then I'm going to export them. I'm going to also export them using my normal export code, export to my drive. Okay, and so what I'm going to export the images, the 2 images. That must be 2000. Hey, concentrate. And this must be 2021. Ish. Okay. Where is it giving me now a problem? Shouldn't give me any problems. Okay, my scale is 30 meters, and I'm exporting it to my project folder in my Google Drive. Okay, so you must go to your Google Drive, create a folder, call it project, also with a capital P, and obviously it's clipped around my region of interest. And I do the same for 2021. Okay, so what I'm doing here, I'm generating 2 images. I'm summing that I'm generating 2 sum clipped images. One for the beginning of the data set and one for the last image of the data set. I created my visualization parameters, and then I'm going to display my images in my map, and I'm going to export it to my Google folder. And I do the same for SEDAC. Okay, there's my SEDAC name. Again, same code here. There's the band, so population count. Here this is called population. So I'm not going for population density, I'm going for population count. Again for 2000 and for 2020. There's no updates behind it. Also with some variable. Okay, clipped visualization parameters exactly the same. I just call it 1. For if I want to have a differentiated visualization palette for each of the data sets, I add them to my map and I export it. Okay, and then same for LandScan, exactly the same. I have the unique identifier. Remember here, the band is called B1. Okay, so if you go to band, then it says B1. Okay, so I select B1. Again for 2000, they all have the same starting block, 2000. You can see all the same starting block, 2000, WorldPop. The last image is 2021. SEDAC, the last image is 2000. And LandScan, the last image is 2022. Again, the sum image, and I clip it to my region of interest. I have a visualization parameter. I call it vis2. Remember, vis1, vis2. I load them to my map, and I export them. So the code is exactly the same for all 3, or the basic code is exactly. Obviously, the variable names, the band names, the ending time periods are a little bit different, but the rest are exactly the same. Remember to generate your project folder within Google Earth, because if you're going to go to task here and you want to save it, it will ask to be saved to that folder. If you don't have the folder, you're going to have a bit of a problem. So remember to create your folder within your Google Drive. Okay, and then we basically let me just remember, save, and we run it. I'm not going to run it because I've already run it. Okay, so let's have a look quickly before we okay, so but I don't need this. I need to get out of here. I don't want that. Let's just delete it. I must delete that. Okay, I want the hand. Okay, so there's my code. Let me just save it again. So there's my code to generate 6 images. Okay, I'm going to generate 6 images. 2 images for WorldPop, 2 images for SEDAC, and 2 images for LandScan. 2020, 2020, 2000 and 2020, 2000 and 2021 for WorldPop, 2000 and 2020 for SEDAC, and 2000 and 2022 for LandScan. They are summed images clipped for my region of interest. they have the same visualization parameters or palettes. Okay, so they've loaded. There's my region of interest, just to show you again, my region of interest. Okay, so let's go to WorldPop, and you see there's the WorldPop image. Now, you see WorldPop have, where there's rivers and mountains and stuff, they have no color. They don't have, if they've excluded that from the image, you can see there. Okay, so if I go to satellite, you'll see the satellite images will appear there. Okay, so they've decided not to fill that specific areas. Okay, but let's go back out again. And that's why you'll see there, if I go to map and I add my region of interest, that's why they're blue, because my region of interest is blue. Okay, so it's not that it's a river or any color, it's just they've no pixels there. Okay, so there's so let's delete it. So that is WorldPop 2000 and WorldPop 2000. Now you can see from this angle, you can't really see much. And that is because it's such a low resolution. So with WorldPop, you really have to zoom in to see where but you can see there's some population located there, there's some population located there, and there's some population. And so from this wide angle or from this distance, I can identify 3 population centers. Maybe there's something there as well, but there's 1, 2, 3 population centers that I can identify from this angle. But you can't really, you can see that's 2000. Have a look at this particular area. You can see it's fading, and then if I go to 2000, you can see it's much more sharper, meaning more to the red side, which means higher population count. Okay, so now remember this is 92 resolutions, meters resolution. Now let's have a look at SEDAC. You can see the SEDAC resolution is much bigger. Remember that's to 1000. Have a look at the difference. You can see clearly the resolution difference. Okay, so that's 2000 SEDAC, and that's 2020 SEDAC. Okay, and that's LandScan 2000, and that's LandScan 2020. Oops, there's a name, that's a reference again incorrect. That must be 2022. Okay, let's save it. Before we run it again, I'll run it now. Okay, so there's 2000 LandScan, and there's LandScan 2020. And you can see, if I take this away, you can see the resolutions between SEDAC and LandScan exactly the same. Have a look at this area here. You can see the resolutions are basically the same. So that's your 1000 meters, but obviously it's much higher. Let's go to WorldPop. You'll see it's you'll see it's much higher than WorldPop. You can see clearly the difference between the two. Anyway, so let's quickly. So that's the 6 images that we've created. I said the WorldPop 2000. Okay, so let's quickly zoom into this particular town. Okay, we know this is a town. If I unselect all my images, I put it on a satellite, you can see this is a town. In fact, this is the town that I stay in. I'm not going to show where my house is, but anyway, my house is somewhere around here. Okay, so this is the town. That's the Berg River going into the ocean, coming from the Paarl area, etc., etc. This is the town. Okay, so we know this is a town, so we know there's population. So let's put the WorldPop 2000. You can see WorldPop 2000 indicates the highest population count. It indicates population there, but fairly low count, high population count. Remember, this is population per square. Now let's quickly drill in. You'll see there's a square. You'll see the square. Let's make sure. You'll see there's the square. You can see the square. Okay, that's what it's 92. Okay, 92 meters is that square. Let's just quickly, for intersect, activate LandScan You see the difference between LandScan. LandScan is much bigger. LandScan is almost double the size. LandScan. Let's go to SEDAC. You see SEDAC as well. Okay, there's LandScan. See, LandScan and SEDAC very similar in terms of the size of these squares. You can see there's your square or your pixel. Okay, so you'll see that's the LandScan. Similar, virtually similar to your SEDAC, which is obviously much higher than your. So that's, yeah, it's much higher than your WorldPop. WorldPop is about half. Okay. Anyway, so you can see that's why I like it, because WorldPop much closer represent the underlying settlement or underlying population. You can see there. If I undo that, you can see it's much closer linked to these areas because it's so small. So it is much more representative of what's actually happened there in reality. Whereas SEDAC or LandScan, let's for example say, you see it's much bigger, so it overlaps multiple areas. So you don't know, yeah, so it's not as representative. Okay, you see there, it's for example have this mass, let's have a look. You see, so in this area, you see there's no people living here, but the square will overlay this specific area where there's no people living. So you would, yeah, okay. So, I think you get the idea. Okay, so that tells you the spatial resolution. Okay, so yeah, so okay, have a look there. We can see that was WorldPop in 2000. Let's make it that. There's WorldPop in 2020. You can see some. Remember, the more to the red side you go, the higher the population. The more you go to the black side, remember it's black, green, etc., etc. So you can see there some. If you look at SEDAC 2000, there's SEDAC 2000, SEDAC 2020. There's your LandScan 2000 and your LandScan 2022. Okay, so in all cases, there's definitely an increase in population within this region. All three data sets support this argument that there's been an increase, and you can actually define where is the increase. Not just there's an increase in the whole region. You can actually pinpoint and say in that specific square, whether it's 92 or 1,000 meters, there's an increase, and you can actually calculate by how much. So, for example, let's say we want to go this particular area, and let's click this. This is a newish informal settlement. Let's click on this area. Okay, so it will give you. Okay, let's just make it bigger. Let's just draw it. It will tell you, according to LandPop, there were 67 people in that square, in that 97 meters, and it doubled to 142. Okay, SEDAC, there was 2,902, but remember that's now 1,000. Okay, so remember you have to adjust the two so that it's the same. Okay, because remember this pixel is much bigger, but also a doubling, roughly a doubling. Okay, so that number is less than that number, but it's because WorldPop has a much lower pixel value than SEDAC. So you can't just compare the two. You have to, for example, take them to 1 square meter or 1 meter, and then you can get that. Then you get a similarity between the two. And if you look at LandScan, LandScan said there was 10, now there's 739. One would have thought that between SEDAC and LandScan there would be much more closer similarity, but it does not. But again, don't take these numbers on face value. You have to actually drill down, go and have a look, figure out, and then make similar comparisons, apples with apples. Okay. Well, thank you. This is the start of our population journey within remote sensing. As I said, we've gone through the nighttime lights journey. We went through the daytime imagery journey. Now it's time for us to explore the population data sets and see what interesting things we can learn from these data sets and what value it can add to our day-to-day life. Okay. Yeah, thanks for staying with me. Thanks for watching this video. Again, please remember to like and subscribe, and feel free to share these video tutorials far and wide. It's always nice to see the subscription and view of these the video tutorials increasing. So I very much appreciate all the support, and yeah, I'll see you on the other side.